Picture this with me. There's a wormhole. One mouth sits right next to Earth, while the other is near a star 100 light-years away. You step inside, and just a few seconds later, boom, you pop out on the other side. Now, here's the big question. During those few seconds you were inside, how many years actually passed back on Earth? If your first instinct is to say 100 years because the star is 100 light-years away, do me a favor. Forget the term light-year for a moment. A light-year is a measure of distance. It isn't some kind of time toll the universe forces you to pay. If the two wormhole mouths are still perfectly synchronized, taking that shortcut doesn't suddenly make Earth 100 years older. And this is where things really start to get wild. So when exactly do those 100 years pass on Earth? Before that can happen, something pretty mind-bending has to happen first. Imagine we take one mouth of the wormhole, load it onto a spacecraft, accelerate it to nearly the speed of light, and then bring it back to Earth. According to Einstein's theory of relativity, the clock attached to that moving mouth would run much slower than the clock we left behind on Earth. This is the classic twin paradox. One twin stays on the couch. The other takes a high-speed rocket trip through space. When they reunite, boom, they're no longer the same age. Now swap those twins for the two ends of the wormhole. They used to be just two doors connecting different places in space, but now the clocks behind those doors are completely out of sync. And that time gap is exactly what lets you step through in a matter of seconds and walk out into another era. So if you're asking what actually happens to Earth while you take a shortcut across 100 light-years in an instant, the answer doesn't depend on the physical distance at all. It depends entirely on the clocks at the two wormhole mouths. If both mouths are still perfectly synchronized, you might disappear for only a few seconds, and only a few seconds would pass back on Earth. That makes sense, right? But what if we make one of those mouths 100 years out of sync with the other? You step in today and pop out on the other side 100 years in the future. And that's where our brains start to get confused. A distance of 100 light-years tells you only how far apart two places are in space. It tells you absolutely nothing about how far apart their clocks are in time.